So, hello everyone, this is the channel about engines. I'm starting to assemble this engine. This is an ZMZ523, a V-type carburetor gasoline engine. V-type carburetor, 8 cylinders. The technical specifications will now appear on the screen. The engine has been removed. This is a bus like this, a PA Z bus. I think it's from 2013 or 2012. This bus is used for orders, and some events are also held in it. The owner of this bus is a woman. I have a disassembly of this engine on my channel. The link is in the description under this video, so those who watch the disassembly remember what condition the engine was in and how much buildup there was here. In general, I already washed it somehow using a jet washer with chemicals and a pressure washer, and I also scraped something off by hand in some places. Now I just took it out of the washer. There will be some footage. Blew it out. Well, there's still work to do. Of course, I need to open up the oil channels in the block, blow them out, clean them, although I already washed them with a pressure washer right into the oil channel opening. I put the nozzle in there, and under pressure everything got washed out. Well, in any case, I'll open up the channels here again if possible. Like, I'll unscrew these plugs and blow them out, clean them maybe with brushes mechanically, with chemicals. So I'll still work on the block some more. I also need to clean all the studs, and I still need to remove the old gasket. It looks like it's stuck here. You could say it's become one with the block. So there's still work to do on the block. I'll leave it for now. We'll come back to it later. So right now I'm working on the cylinder heads. Mark the valves according to their positions. Which valve is from where, and put them in a container. So now I want to soak them in a solution and see how this solution will work on the carbon deposits. Well, basically I want to try to clean them. So we're keeping these valves. I need to clean them and then check the condition of the bevel that sits on the seat once they're clean, and maybe machine them and lap them as well. And the cylinder heads are also going to be washed now. You can see how much buildup there is on the heads. Basically, the whole engine was covered in this kind of buildup. If you haven't seen the disassembly episode, you can clearly see here what condition the engine was in. So I'm sending the cylinder heads to be washed. I'll soak them until tomorrow. Basically, they'll stay in the solution for a day. and then I'll wash them off with a pressure washer. Well, basically using all sorts of different methods. After the cylinder heads, I'll work on the crankshaft by unscrewing it. To do this, I remove the flywheel's 4 nuts, take off the flywheel, then unscrew the plugs. I also need to clean the crankshaft recesses and channels, and it also needs to be cleaned because there's a layer of carbon buildup a few millimeters thick here, and after all that I'll polish it. There's a little bit of wear here, but for this crankshaft, for this engine, that's actually pretty good. Usually it's much worse here. So I'll polish it and then I'll start assembling everything. So the camshaft, I've cleaned it for now, but I don't know yet. Itva, there's still no decision whether we'll keep this camshaft or use a new one. We're waiting to hear the price for these parts, and then the customer will decide what we're going to do. Well, basically this camshaft, I cleaned it up a bit and it's actually still pretty good. And I also sent my pistons. Some of them got cleaned up, some didn't, but still, there's no decision yet about the pistons. Maybe I'll get a new set. In that case, I'll just take these pistons off the rods and put on new ones, and that'll be much easier and much better overall. That's the scope. Let's begin. So basically I'm leaving it for a day. If it works, I'll share the mixture recipe in the video. If it doesn't, well, we'll see. Let's wait a day and then we'll figure it out. Alright, so open the plugs and see that the entire compartment, all the holes, the whole cavity is completely clogged with deposits. I haven't seen anything like this in a long time. It used to be normal when I often repaired these engines, but later, when the oil became more or less good, this stopped happening. Usually when you open it up, there are just a few deposits from the centrifugal force. But here we can see that the hole is completely blocked. There's no hole at all. You can't even see through it. Well, on this side there's a small hole on this journal, but on both sides everything is completely blocked. Well, basically this is what it looks like. There are that many deposits in there. Well, Actually, this isn't even the most dirt I've seen in these crankshaft niches. Sometimes you can't even get it out with anything. It's so compressed that you have to drill it out with a bit. That's how it was before. So I remove the chamber, clean it without the chamber, because you need to blow it out here. You need to use a metal brush here. It will spray all over the chamber. So I remove the chamber and clean it. Crankshaft. I've almost finished preparing the crankshaft. I washed it, cleaned it, blew it out, polished it, and the plugs with thread locker, and replaced the thrust rings along with the bearings. They're all new. I installed the key, put this washer in place. Usually this washer gets worn out, so you either have to replace it or, for example, grind it down. Well, in this case everything's fine. I installed this washer, installed the gear while it's hot. It's lying there on the stove, heating up. I don't press it all the way in. I leave about 3/16 of an inch, not all the way, just like that. This is so that when you install the crankshaft, these rings don't get in the way. So later, after I install and tighten the crankshaft, I'll tap the gear in a bit more and it'll get pressed in further as well. With the hub, the gear presses against this washer, the hub presses against the gear, and the ratchet tightens and presses against the hub, so it all gets pulled together. So you just need to tighten it well. You might have to tap it a bit, tighten the ratchet, tap it a little, then tighten the ratchet again, so everything fits tightly. Sometimes there might be a gap here when the engine is running. That is, after the engine runs for a bit, this gear settles into place, then the shaft moves back and forth, wearing out the rings and washer. So it's really important to tap and tighten it several times. Alright, so I'm installing the gear and then I'll see what's next. Either I'll put on the flywheel or I'll start working on the cylinder head. Okay, I knocked out the old guides April 17th, 1704. 1704. May 17th, 1704. 1704. So I changed the guide on this head. As I already said, the intake valve, here the guides are basically in good condition, and also each valve is marked for its place. So here I'll just make the seat, make the working chamfer narrower, and lap the valves in place for the intake valves. There are some minor defects on the working surface here, so now I'll machine them on the lathe at a 45-degree angle. I've already replaced the guide here. I'll first ream the working chamfer, then make it narrower at the top and bottom, remove it, and then of course I can lap them in any order because both the seat and the valve itself have already been processed. But in any case, I already have marks here, so I'll, for example, this is the fourth one, and I'll do the same for the second head. I still don't know. I'm thinking whether I need to machine them on the lathe or not. Maybe just do my own thing, because first of all, I've never seen aluminum heads being machined on a lathe. Well, in general, you can see from the abrasive that it was ground with a stone. I don't know how they do it like that. Usually, non-ferrous metals aren't ground with abrasives, only with a cutter. Well, as I understand it, I think you need to clamp it in the machine and remove at least the minimum possible 5, 6, 7, 800ths or up to a tenth. I'll probably do it that way. Well, first I'll lap the valves, mark them, then machine them on the lathe, assemble the cylinder heads, and then we'll work on the block. So, first I work on the exhaust valves, where I replace the guide bushings. First I cut the 45-degree working bevel. When you replace the guide bushing, there are always some misalignments. They can't be perfectly perpendicular to each other. Next, I cut the top and bottom bevels, making the seat about 1 millimeter to 1.5 millimeters wide, give or take. Basically, all the seats are coming out well. The seats are soft. So, I finished working on the exhaust valves, and now I'm just slightly cutting the top and a bit of the bottom of the exhaust valves right now. The width of the seat in the working bevel is about 3.5 millimeters. I'm going to make it about 1 millimeter to 1.5 millimeters. Here's how my valves look now, ready for lapping. As I said, I just cleaned the intake valve and now the exhaust valve. There were shots of how I was machining this working bevel, so I put them in order: first cylinder, second, third, fourth, and now I'm lapping them. I prepared the paste. Then the heads for resurfacing. Like I said, I want to take off at least 1/10 of a millimeter. Then I'll assemble the heads, and tomorrow I'll weigh the block and put it on the stand. I got everything ready here, cleaned up. It was a mess before. Tomorrow I'll clean it, and maybe tomorrow I'll install the crankshaft right away. Maybe the day after tomorrow in the morning I'll already have the new pistons. Well, in general, things should get going now. The prep work is almost all done. Now, we'll start assembling. We're about to start assembling. That's it. You could say the valve is lapped. We can see the track is even continuous right in the middle of the valve, in the middle of the working bevel. Here on the seat as well. There's a continuous shine all around. So basically these heads lap really well. I mean, no problems at all. This isn't a foreign car, not a MAN, not a Mercedes. You can really struggle with those valves there. The seats are lapped completely differently and the valve material is totally different. What I like about the seats here, especially in our engines, specifically in this 100 valve one, is that lapping them is just a pleasure. Just a few minutes and the valve is ready. You could hear that the squeaking had started, which means the seat has been finished. You can see the shine all around. A continuous track, and the valve itself looks just perfect and textbook. Everything is great. That's all. So, the first cylinder has been lapped, or rather, this is the fourth one. The fourth cylinder is lapped. You can see the mark 4 on the valve. And I'm also lapping the other 3 cylinders. And next I'll take the cylinder head to the machine for resurfacing. So, I machined one head, everything went well. I took off about 1/10 of a millimeter, maybe a little less. Everything turned out fine. Then I put the second head on, clamped it down, secured it, and right away I noticed that something was off. Basically, it just doesn't sit right at all, it's being pulled somewhere. As I said, the customer gave the heads away, meaning they wanted to install them right away, remove them, change the gaskets, and install them immediately. Then he sent them somewhere else to have them ground with abrasive. So as I showed earlier, you can even see the difference, right? Between how it's processed with a cutter and how it is with this abrasive. It's all kind of wavy like this. So I put on the second head, made one pass, also 1/10, and we can see this whole side is being cut, and the closer it gets to this corner, it turns out this corner is slanted over here, so we can see it. Here the cutter isn't cutting. Here it's not cutting, here it's not cutting, and here, starting from here, it starts to cut right here. He said that when he picked up the cylinder heads, they told him that one head had something wrong with it, like some angle was incorrect. As I understand it, they just clamped it incorrectly on the machine, and they ended up with some wrong angle. They shaved it off from this spot. I just measured this height with a normal head, and I also measured the heads I have. This height here is almost 1.5 millimeters lower. Well, I don't know. I'll finish it now, and when it's ready, I'll take some measurements. Maybe they completely ruined this head. Well, I don't know. So, for now, there are no solutions. I'm just showing that this problem has come up. So, now I'm going through another 10 and let's see what we get. Alright, so the cylinder heads are ready. I'm assembling them, installing the washer, putting on the valve stem seals. Then I've prepared the springs and keepers, assembling the heads, and then I'll start working on the block. So the block is ready. I've cleaned everything, the gaskets, some carbon deposits, dirt, degreased some areas, opened up the channels. As you saw in the previous shots, cleaned them as much as I could, blew them out, put the plugs back in, installed the fittings, everything's done. So the block is ready for assembly. So I'll start assembling by installing the camshaft. The camshaft will be new, so I need to remove the bolt from the old camshaft. Here's the drive. This eccentric is for the fuel pump drive, and these are the counterweights. And also on this side there's a thrust washer, and under this washer there's another small washer. So I'll take all this off, clean it, probably right away in the sandblasting chamber, and then I'll assemble it with a new camshaft, a new gear, the same kind that was installed before, made of Caprolon. I try to use only Caprolon gears because there was also a Textolite one. There are several types. In my experience, there have been several cases where they slipped. Well, actually the teeth got sheared off, since this gear works together with a metal gear, and it's on this gear that the teeth get sheared off. With the Caprolon one, I've never seen this happen before in my experience, but with the Textolite ones it happened a few times. So I try to use only these gears. Alright, so we start with the camshaft and then move on to the crankshaft and the piston. Basically almost everything is ready on my end. Now I just need to assemble everything quickly. Assemble, assemble, assemble. That's the amount of work I have. Let's go. So let me remind you again, why did we decide to change the camshaft? Here we can see the cam lobe has started to chip. This is the worst lobe, and there are a few more like this here and there. Several cam lobes are in this condition, basically like this. So I told the customer that in principle this camshaft can still be left in. It will work for some time, but you have to be ready for it to keep chipping further. All of this, the metal shavings, will go through the system. So the customer decided to buy a new camshaft, and the new camshaft costs about 6,000 rubles. That's pretty much it for us. Well, it's already the winter of 2025-2026 December. Well, again, it's not really fair to compare, right? For example, a camshaft for MAN might cost around 150,000 rubles, but here it's 5,800, I think, if I'm not mistaken. So I installed a new camshaft. I didn't touch the bushings. Everything's fine with the bushings. And even after installing the new camshaft, it turns with just a little bit of resistance. That is. The journal of the new camshaft is just a couple hundredths thicker. And even if there was some minor wear in the bushings, that's on us. Everything was commented on everything. So the camshaft in place. I tightened this bolt with thread locker and also tightened these two bolts with thread locker. The longitudinal movement is about 0.1518 and the longitudinal movement is adjustable. So I was setting those washers, installing those two washers, meaning the difference in height between these two washers is what determines the longitudinal movement of the camshaft. Well, I checked there's no wear at all, so I put everything back as it was. The camshaft is in place. Next, I unpacked the piston group and installed the sleeves. So this is a new piston group. Our engine, the part is from Kostroma Expert. Well, I don't know what the quality of these parts is like now. As I said before, I haven't assembled these engines for 12, 13, maybe 14 years. That's for sure. I see. The kit includes a piston, but I haven't unwrapped the cylinder liner yet. Everything is still in plastic wrap. I recall when all of this was packed in paper, I used to install Kostroma motor and detail parts back then.
Piston. Well, we can see that everything here is just like in real cars. We have an anti-friction coating. And we also have rings for the cylinder liners in the kit, a copper sealing ring, so it comes in two sets of 80. Here we have the retainers for the piston pins. Here are the piston pins themselves. And the piston ring, each piston has its own step back.
I fully prepared the crankshaft for installation, installed the flywheel bearing and the new disc. The rubber we have is old. Well, of course, this could have been installed later on the spot, but it's inconvenient. The casing is in place, so basically you need to turn it here. It's easier to install the crankshaft right away with the disc and the basket. So that's it. My basket is installed and tightened. The levers, though, probably need to be adjusted a bit. They're too far in. They've gone over there, but I'll adjust them now. I installed new longitudinal movement rings, as I showed earlier. I also prepared the bearings and caps. I cleaned them in the sandblasting chamber. They were all covered in carbon deposits, and the wash didn't clean them very well. So the packing comes in the gasket set. Just a simple ordinary one, like from Soviet times. Well, in theory, if you install it properly, it basically works and lasts. But I still prefer to use this kind of packing. Here I have the camshaft already installed. Everything is tightened. I also installed the sleeves. I put the sleeves on with a copper ring sealant. I lubricate this with sealant. First on the sleeve, then the ring, then a thin layer of sealant on the ring, and then I install the sleeves, pressing them in. It's important to press the sleeve in. I'll unscrew the ring, tighten it. Subtitles by Dimatersok. I will press the ends of the sleeves, pressing the construction. At least that's how I always do it, I don't know. Maybe someone does it differently. That's all. So I install the crankshaft and then I'll work on the pistons. I'll put them on the connecting rods. Put on the piston rings. First, I install the oil seal packing here in the block. Install the crankshaft, tighten it, and then I install this upper cover. The upper oil seal packing cover with tabs. Also with packing. I apply sealant in this spot. So when I install the packing, first I take a whole uncut packing and I just need to make it flat. That is, right now it's roughly square in cross section, but we need to make it flat because in the block there's a groove and it's flat. Yes. Don't be afraid to work boldly with the hammer. So, as you can see, it became a bit different for me. On this side it's still square. On this side it became a bit rectangular. That's it. So now I'm setting it into the block, pressing it in well so it sits, and I'm leaving about 3/16 of an inch of extra material on each side, so that later the top and bottom will match. It's generally connected. I pressed it again for you. So I always tap it with the handle of a hammer to make sure it sits in there tightly. You need to press it in as firmly as possible. If you just insert it by hand and trim it, then when you install the crankshaft, it will simply get compressed and gaps will appear here. And then naturally the oil will start to leak. So I make a mark. Well, I see that on this side it sticks out about 3 millimeters, and I do about the same on the opposite side. And now I can take it out and cut it along this mark. Everything is cut, and then I install the packing in place. Alright, I see. I don't really like this side a little bit. Alright, but here I think there are about 2 extra millimeters that probably need to be removed. So I put in the packing, and we can see here it's about 2.5 millimeters, and here it's also about 2.5. So now I'm installing the inserts, and you definitely need to grease the packing itself with oil. At least that's what I always do, just a couple of drops of oil. And when we install the crankshaft, when we tighten it, at first the packing will be very tight. I mean, it will hold it, and the crankshaft will turn very tightly. The packing is correctly installed. We can see that we already have one set of bearings, meaning 5 with a groove and a hole, and 5 solid ones. As far as I remember, before all the bearings used to be the same, so there were 10 identical ones. The set used to have 10 identical bearings, and you could install them in any order. Here we install the ones with the groove into the block, just like on any engine. So I tightened the nuts with the impact gun almost without any effort, and now we torque them to 115 Newton meters. So I also installed the oil seal packing into the cap. It's sticking out by about 2 millimeters. Then I install the locking tabs and apply some sealant. so I'll tighten it, but you can over tighten it either. The studs are screwed into the aluminum here. Plus the nut itself can also strip the threads. So now I'll tap it through a piece of wood, then turn the crankshaft a few times, tighten it again, and turn it again. Basically, so that this gap that's left, or rather this 0.5 millimeter, so that this cover sits as deep as possible, and basically that's it. The crankshaft is installed. That's it. I lowered the cover completely, tapped it, turned it, tightened the nuts more, it went all the way down. We can see that the flags barely came out, and that's how it's supposed to be. Sometimes when you install it, the flags start pressing here and then you have to cut them off, which isn't very good. But here, as we can see, everything fit perfectly. And you can turn the crankshaft by hand. Basically, the crankshaft and the camshaft. Like I said, the packing is holding very tightly right now. There you go. And also don't forget about the timing marks. I didn't show them on camera when I set them. On the camshaft, on the gear, we have a slot between the teeth. On the crankshaft, there's a mark, a tooth points to it. As you can see, the marks are aligned, the slot and the tooth. That's it. The crankshaft is installed, the camshaft is installed, everything is tightened. Remember here that the gear isn't fully seated yet, so it's easier to install these thrust rings. So when I install the front cover and the hub, I'll need to tighten everything well. Also tap it in, tighten it again, and tap it again to make sure everything fits tightly here. Alright, next I'll install the front cover. I've prepared everything here, washed, cleaned, degreased, blew it out, the new oil seal. Already put on the gasket, applied sealant, filled the gasket. And now I'm also applying a thin layer of sealant to the cover. And right away I'll probably install the pump, the water pump. Since we have common studs here, they press down on two gaskets at once, the front cover gasket and the pump gasket. And since sealant has been applied, we need to tighten it all up right away. I'm installing the cover, installing the pump, and tightening it all up. Don't forget to install the oil deflector as usual. You often forget to install it. Alright, well, I'll go ahead and install the legs right away, so I can clear up some space on the table. Then I'll start installing the connecting rods onto the pistons. Alright, so this is the pump. It's the first time I've seen a pump for this engine with an aluminum housing. Usually it's cast iron. This manufacturer, this brand doesn't mean anything to me. Wow, like I said, I haven't worked on repairing these engines for a long time. If anyone knows, write in the comments, do these pumps last or not? So this is our lightest piston. Well, in general 715. I don't remember 3 or 4 pieces. 715 grams, that's the total weight piston, pin piston rings and clips. The lightest is 715, and so the heaviest piston, well, 718 grams, so only a 3 gram difference. That's normal, even excellent. So, next, I'm installing the pistons onto the connecting rods. Here we have a piston. It has a marking on the front, as you can see, and if you look, you can even visually notice that the hole for the piston pin isn't centered. It's offset to one side. The distance is greater here and smaller there. All pistons are installed with this marking facing forward, but the connecting rods are positioned differently. It turns out that the locks should be installed facing the manifold. So like this, if the connecting rod is on this side, then it faces forward with this part, where we don't have anything. One side has numbers, the other doesn't, so that's how to position the connecting rod when installed on this side. And it turns out, if we install it on the opposite side, the lock should also face the manifold. Then the opposite part of the connecting rod will face forward. We can see where the numbers and markings are. So on this side the connecting rod is positioned like this, and on the other side it's positioned like this. So from the first to the fourth piston, the connecting rod is installed with the unmarked side facing the pulley, and from the fifth to the eighth, the connecting rod is installed with the marked side facing the pulley. Also, I want to show that the connecting rods are in place. We didn't change the old bushings, and I want to show how well the new pin fits into the second bushing. You can see. Considering that this is an engine from 2012 or 2013, which means it's already 12 years old. It's unknown how many miles it had before this time, and we can see that the bushings are just in excellent condition, in great shape. So what's my point? Well, my personal opinion is that compared to, let's say, engines from the 1990s back in Soviet times, when I started my work, I mostly worked with those engines. With the ZMZ523 and Zavody Likachova engines, things were much worse then. Those bushings needed frequent replacement and constant reaming. So if a connecting rod lasted 12 years back then, there would be a huge amount of play in it. In this case, everything looks just perfect. So my personal opinion is that even our Soviet engines, they've started making them better anyway. Alright, so I lubricate everything, install the pistons onto the connecting rods, install the piston rings, and today I need to install the piston block and close the oil pan at the very least. I've installed the first 4 and the 5th is already in place. Now I'm installing the 6th, 7th and 8th. So I insert it through the feed, apply some grease, tighten it first with the wrench, then we pull with Newton meters when tightened. Both connecting rods should be like this. Move smoothly. That is, they shouldn't be tight. If they're tight, it means either the caps are mixed up or, well, in general, there's some kind of problem. They're tight, they shouldn't be. They should move smoothly with just your hand's effort. That's it. So I've already installed 5 of them. I'm installing 3 more, and probably I'll close up the oil pan today as well. I'm installing the cylinder heads. The heads are already prepared. I showed earlier, so I'm using these kinds of gaskets. They're also metal asbestos, but this one is on both sides. Basically, these metal sheets thin. Basically, I don't know, they say these gaskets are better, but I haven't had experience working with these kinds of gaskets. Write in the comments if you've come across them, if you've worked with them, how are they in general? Well, they're 4 or 5 times more expensive compared to regular metal asbestos gaskets. Well, in general, I don't know, we'll see. So basically the gasket can be installed either way, on either side. The only thing we need is for the oil channel to line up. Here we see the channel in the block, and here is the hole, meaning there is no hole on this side. Well, obviously if we install it like this, the oil will bypass the channel. So I installed the gaskets and noticed that the cooling channel holes are not the same as, for example, the metal asbestos gasket from the set. Here we see large channels at the top and bottom, but on this gasket there are only 4 large ones. The rest are just small holes. There are reviews that were updated after a year, meaning someone installed it a year ago and then updated their review a year later, saying everything is great and there are no complaints. I remember that in the past, sometimes we would come across metal asbestos gaskets with the same small cooling holes, and we installed them too. As far as I recall, there were no complaints about them either. So I'll start tightening the nuts with the impact gun, setting it to level 1. Then I'll use a torque wrench to tighten them to about 8 to 8.5 kilograms. To be continued. Definitely. After you tighten the head, check it from the inside, because at first the middle tightens, but then when you move to the edges, the middle loosens. As you can see, the middle has turned a little, the bolts there just by 5-10 degrees. And now, the closer I get to the edge, the less the nuts, not the bolts, will turn. I've installed the rocker arms. I'm adjusting the valves. So we bring the first cylinder to top dead center with compression. We turn the engine clockwise until the intake valve operates. Once the intake valve operates, we catch the piston at top dead center, and that will be our first cylinder. So, compression. Well, on this engine, I adjust according to the firing order. That's just how I'm used to doing it. There are several ways you can turn it over twice and adjust everything, but I adjust according to the firing order. So, we adjust the first cylinder, then mark the pulley at 90 degrees. Turn it 90 degrees to the next mark. Adjust the fifth cylinder, then another 90 degrees to the next mark. Adjust the fourth cylinder, and so on. Basically 1, 5, 4, 2, 6, 3, 7, 8. Well, now I'll show you how I adjust the valve using the first cylinder as an example. We see that we have the exhaust is working the valve overlap, basically on some cylinder that works in tandem with this cylinder. Where it worked, we have the intake valve, That's it, we have top dead center on the first cylinder. For compression, I set both intake and exhaust to 0.35. So I made a mark on the cover with a marker and also on the dust cover. I made it at 90 degrees as well. Well, give or take here. So I turn it 90 degrees after the first cylinder. I adjust the fifth cylinder, then another 90 degrees, the fourth, and so on. That's it, now we adjust the fifth cylinder. So I adjusted the valves, already went to the bus, took the distributor, installed it on the drive. Well, basically, I need to figure out how to install the drive. Right now, my first cylinder is at top dead center with compression. Here's the mark. And it turns out it's the first cylinder. I just adjusted the valves on the first cylinder, installed the distributor. And here we can see the mark. Here's the tab and it's marked in red. So now I'm tightening the drive, removing the distributor, putting it aside since I don't need it anymore for now. And then I'll close the valve covers and the plate. I wanted to finish the engine in these 2 days, Saturday and Sunday. Now it's Sunday, almost 7 o'clock, 6:10. And as you can see, I still haven't finished the engine. I still have plenty of work left. Valve covers, the manifold plate. I also wanted to paint it, for example, and work on the oil pump. Also, I still need to install the fork here. Well, there's still some small stuff to do, like the pump pulley, the crankshaft pulley, oil tubes and mounts. So basically, there's still work left. Here we have the bracket, the drive mount, so I still need to replace it on the plate. Here, the gaskets are a mandatory procedure, meaning if this gasket leaks, there won't be any pressure. We've already discussed this, it's happened before. So right now we have a rubber gasket here. I don't know, I haven't removed it yet. I'll check, but I think there was both a rubber gasket and some kind of washer here. When I blew it out just now, it flew off. I'll get it now. So what we have here is, if this gasket, the rubber one, fails, like if it hardens or cracks, and that's what happens. This is our main oil channel, meaning it's right after the pump. So if we don't have a seal here, all the pressure is lost here, and there's no pressure in the engine itself. So I still need to spend some time on this thing, meaning I need to clean it. Apparently I washed it, but it didn't get completely clean. The gasket here needs replacing. Interestingly, Set B's repair kit includes this gasket, but there's nothing for this location. So now I'll have to think and figure out what to do here. Well, I used to make them out of paronite before. I think I cut out 2 or 3 gaskets from 1 millimeter paronite and tightened them. I don't know. Well, anyway, I'll have to think and see what to do now too. So I want to install this thing first, tighten it, and then install the plate. Also, I have the breather disassembled here. Where is it? The breather is disassembled on this table. I also cleaned and blew it out. Now, I need to clean off the old sealant. This bolt here, by the way, the one I just showed, holds this plate. Also, as you remember, I have the gearbox, so I need to assemble the gearbox. There's little repair needed, but I've already cleaned up what I could. But in any case, I need to install all the bearings there, replace a gear for third gear, I think, the clutch, and so on. So that's all work. Just the gearbox alone will probably take me a whole day. That's why I just can't make it in time. So now I'll put on the valve covers. Basically, I'll work until about 7 o'clock. Get something done here, maybe not everything, and then go home. My day off basically means that instead of leaving at 10 in the evening, I leave at 7. That's what a day off looks like for me. That's it. So I'll tighten the drive, install the valve covers, and that'll be enough for today. So the valve covers are installed with the filler neck on the driver's side. So here we have the 5th, 6th, 7th and 8th cylinders and the valve cover. We can see here we have 4 stiffening ribs, and here there are more. So there are also intermediate stiffening ribs. This part is the bottom towards the spark plugs, basically this part, and the valve cover as well. So like this. Next I install the plate, I put in the gaskets, and honestly, this is my least favorite procedure when repairing this engine. Well, those who know, who have dealt with these engines, they know. I mean, these gaskets here, they never fit right like now. For example, you can see there's a gap of about 3 millimeters. I'll put a drop of sealant here, apply it, so the plate never sits properly. If you don't tighten it enough, coolant leaks, for example, under the plate or from the engine to the outside. If you over tighten it, the gaskets get squeezed out, and then either crankcase gases with oil mist get sucked into the cylinder, fouling the spark plug, or it also squeezes out the coolant channel, and the coolant starts leaking as well. So this is my least favorite part of engine repair. Almost every time after installing the plate, I have some kind of problem. I have to either retighten it or do something else. Honestly, I don't know. Couldn't they have made some kind of stops here, like metal inserts, so you could tighten it all the way and apply a certain amount of force? But here it's just a rubber gasket, so you can keep tightening it as much as you want, but you never really get the right tension. So while I was tightening these, by the time I got to the edges, the others loosened again, so I have to start tightening those again, and you could go on like this forever. What I do is I tighten it just a little bit. As soon as I see that the rubber starts to bulge out, meaning it's starting to deform a bit, that's it. That's how I insert it. And if there are any issues, I adjust it a little bit on the spot. Well, basically I set the plate and we'll see how it turns out. Basically, I tighten it like this. I think that's enough for now. As I said before, if needed, I'll tighten it more on the spot. So now I'll install the breather. I've already installed the base for the oil filter. Now I need to tighten it, and basically that's it. The carburetor will be installed in place. Oh, and now I'll also install the pulleys. Well, I guess that's it for the engine. Oh, wait, the compressor. I'll be working on the compressor now. I was about to say I'll start working on the gearbox. Next, I'm assembling the gearbox. I've already installed the intermediate shaft and everything is basically fine with it. I only replaced the bearings, both of them, and I also installed the reverse idler gear as it is. It's in good condition too. So I've already prepared the output shaft. For the output shaft, I replaced the third gear and the third fourth gear synchronizer sleeve here. I replaced the bearing on the input shaft and installed a new one. I also replaced the bearing on the release bearing. I prepared the cover and installed a new oil seal. Now I'm installing the output shaft, then the input shaft, and then I'll install the front and rear covers. So I don't remember if I mentioned this on camera before or not. Well, obviously those who have worked with these gearboxes know this. But for someone else, it might be interesting that there's a front cover on the input shaft. We don't have an oil seal here, so we see this kind of cup, and inside there's only an oil slinging thread, like a screw, a kind of knurling, a cut. And there's nothing on the shaft itself either, just a polished area that works around this threaded cut. So as it rotates, the oil is constantly pushed back in the opposite direction. I don't know, this is the only gearbox where I've seen something like this. Write in the comments if you've come across something like this anywhere else or not. And as far as I know, oil never leaks from here. It's always dry here, there's no oil seal and oil doesn't leak. And this is our simplest, most basic gearbox, you could say, without any complications. Without synchronizers, a synchronized 4-speed gearbox. I've prepared the bolts. These are the bolts for the top cover. We have the cap, the front cover, and this is the rear cover with the dust cover. This nut holds the flange. Here are the old parts. I've replaced, as I said, all the bearings, third gear, clutch. Well, when I was disassembling, I showed that there was this kind of oil deflector. I don't know, it's the first time I've seen something like this. I've never come across such washers before. In the gearbox, it covered the secondary shaft bearing like this. I chose not to install it since it seems unnecessary. Who put it here? Let me know in the comments if you've seen this type of oil deflector in these gearboxes. Well, that's it. I'm finishing up the gearbox, installing it on the engine and painting it right away. Then I install the engine on the frame and paint it right away too. But I'll say right away. The customer said there's no need to paint it. It's fine as it is. I'll just take a look as usual at what I have there. Most likely I'll just cover it with primer, just a coat of primer. Maybe I'll add some paint if I find something. But basically as usual I'll mix up some kind of stuff and pour it all over the top, just so it doesn't rust. So right now I've cleaned all of this until it shines. Yeah, all the dirt and rust are gone. And if I install it like this, all these metal surfaces will get covered in rust literally after the first trip, but at least this way it'll look decent. Obviously it's more of a decorative thing, but I still want to paint it. I just really do. Neutral. These fourth ones, the first one. That means the first, the second one. The fourth one, neutral. The oil pump last, so I don't have to flip the engine over again later. I just turned it now, finished up a few things and put something else in place. I want to pour oil into the pump now. It's not necessary, but I always do it this way. Fill the pump with oil before installing it on the engine. And accordingly, if I kept turning the engine, all the oil would just leak out. So I install the pump, take the engine off the stand, install the transmission and then paint it. temporarily set the frame to install the transmission without placing it on the oil pan, then installed and tightened the transmission. But now I'll tighten it without the camera, since the camera is in an awkward position as usual. I'll install the fork on this side now, and then I'll close this hatch. Basically, that's it. Finally, it'll be ready for painting too.
Thanks for watching.
Alright, so the engine is ready. The carburetor, oil filter and compressor will all be installed on site once the engine is mounted in the car. So as I said, I painted it using a mix I found here, about 2/3, maybe a bit more primer and 1/3 paint. I had some green paint, so I diluted it a bit, and this the color I got. So I also installed the manifolds. I sandblasted and painted them as usual with heat resistant paint. Here are some studs, new nuts, new washers, new gaskets of course. I tightened everything on both sides. I replaced this tube here, it was rusted through. I also drilled out this base with a drill. Well, actually there was a lot of carbon buildup there, but basically I restored it to how it was. Usually this tube is removed, it goes to the carburetor for heating, but people usually take it out and put plugs in. I did it the way it's supposed to be. The spark plugs are screwed in for now, just the old ones basically as plugs. New spark plugs will be installed later already. I've already installed the engine on the frame of the car, tightened the mounts, and also installed the electric preheater in its place. Here we have a wall heater for 2 kilowatts. I kept flashing it and flashing it. There was so much rust, just as much rust as there was in the water jacket of the sleeves. That's how much there was here too. It was half clogged with that rust. So I kept flushing it, but I couldn't manage to clean it out. So I had to take it apart, unscrew these 4 bolts, took them off, and then I washed everything, blew it out, cleaned it, put it all back together, and installed it. It's attached here just to the mount, to this bolt, which is, well, the engine mount, and also with this kind of bracket. And 2 hoses go into the water jacket from both sides. I installed the hoses in their places here. This is the oil drain from the compressor. This is the oil supply to the compressor, the drain. And this is the cooling for the compressor, and there should be another hose somewhere, the outlet, cooling from the compressor. So the hoses are apparently in this condition. The hoses will be replaced on site. I just put together everything I had. So this is the first time I'm doing a repair like this on a ZMZ523 engine on my channel. And in general, as I already said, I haven't worked on them for about 15 years, give or take. But honestly, I enjoyed it and remembered how it used to be. Well, because when I started working as an engine mechanic, this was one of the main engines that we used to repair. I mean, it's not exactly the ZMZ511, but it's basically the same. Then there were Zavod Imeni Likachova 130 engines with Ural pistons at 108 millimeters and with Zavod Imeni Likova pistons at 100 millimeters. Well, mainly all those Zavod Imeni Likachova and J-Zone engines, yes. Before Mercedes, I mostly worked only with those. So, in general, I enjoyed working with this engine, for a change. The repair of this engine costs this much. Here we have all the parts for the gearbox, for the engine, and plus the removal and installation of the engine is my job. So, as usual, I'll try to film the engine startup in the car. Well, I think that'll be in about 5, 6, 7 days, basically about a week. I'll try to film it and keep going. Now we're going to have some footage of starting this engine. Well, at least there should be all of it. So I'm going to end this video here. Thank you all for watching. Good luck to everyone. Bye. The temperature is about 70 degrees and the pressure is 1.5 units, 1.5 when it's hot. Well, basically for this engine that's normal pressure, it doesn't get any higher. Well, I see the new pump is leaking and the sound there is because the air supply to the compressor hasn't been connected yet. That's why it sounds like that. So basically it runs smoothly. As we can see, the temperature is over 70, 75. The pressure here shows about 2, and I increased the RPMs a little bit. So no, the pump is new, maybe it still needs to break in. There are ceramic washers in there. Well, in general about the fun, I don't know yet. If hits like this, that's what happened. They didn't warn me. If they had told me, I would have changed it, put on a different hub, a different skiff. That is, the hub itself apparently has this kind of groove. Right now we have a temperature of 80, the lowest possible revolutions per minute, and the pressure here shows 1 unit. So this is 5, this is 2.5, and minus 3 divisions of 0.5 is 1 unit. Well, for this engine, that's perfectly normal pressure. I don't think I've ever seen these engines with higher pressure. I'll leave the contact information of the owners of this bus in the description below the video. Maybe someone would have questions, or, for example, someone might be interested in ordering such a bus for some events. In general, the contacts are in the description below this video.